Welcome to the deep dive. Today, we're digging into, a really ambitious idea from your sources. It's all about reaching space, but maybe not how you'd expect. Not with rockets, imagine. Just riding an elevator. Straight up. Sounds like science fiction, right?
Yeah.
But we're going to unpack the concept because, rockets, they're incredible machines, absolute marvels. But let's be honest, they have drawbacks. Huge ones. They're complex. Incredibly expensive.
And inherently risky. There's always that element of danger.
Exactly.
And fundamentally, if you look at the physics, it boils down to something often called the rocket equation. Basically, it tells you that getting anything into orbit means carrying a ton of fuel. And then you need more fuel just to lift that fuel.
It's a vicious cycle.
Yeah, compounding weight problem. It just makes everything massively inefficient and drives up the cost like you wouldn't believe. So that inherent limitation, that's really what sparks the search for, completely different ways of thinking about it.
Okay, so if rockets have this built-in problem, what's the alternative we're exploring today? Like I said, imagine stepping into a lift, an elevator to space. We're going deep into this idea of the space elevator. Could it be safer, simpler, cheaper even?
Potentially, yes. At least for reaching geostationary orbit.
And your sources describe this thing. It's just staggering. A tether, right? An incredibly long cable, stretching something like, 23,000 miles from Earth's surface straight up.
Roughly, yeah. All the way to geostationary orbit. That's the sweet spot where a satellite stays over the same point on Earth.
Just to give you some perspective, that's way, way beyond the International Space Station, like 6 times Earth's radius further out.
It's almost impossible to grasp the scale. I mean, think about it. Any structure we build so far, this would dwarf it by orders of magnitude, pushing up through the atmosphere out into the vacuum.
It's a truly mind-bending engineering concept.
It really is. Even thinking about it is a testament to, human ambition.
But ambition meets reality pretty quickly here, doesn't it? Building something like that, the challenges must be immense. Engineering, materials.
Oh, absolutely. Huge hurdles. We're talking fundamental problems in material science, for a start.
Okay, so let's get into those. What are the big roadblocks? The how and the why? This is so incredibly difficult. We've sort of sketched out this amazing vision, this elevator climbing into the sky, but making it real? That's the tough part. And it sounds like the absolute crux of the issue, based on your sources, is materials, right?
Exactly. That's the linchpin. The whole concept hinges on finding, or rather making, a material that can actually do the job.
Because traditional stuff, steel, titanium, whatever, it just won't cut it.
Not even close. They're simply too heavy for their strength. A cable that long made of steel would snap under its own weight long before it reached orbit. You need something with a truly extraordinary strength-to-weight ratio. Something almost unbelievable.
And the candidate material everyone points to is carbon nanotubes?
That's the one. They have incredible tensile strength, hundreds of times stronger than steel, but they're incredibly light. Theoretically, they're perfect.
Okay, theoretically sounds like there's a catch.
There's a big catch. Right now, we can only manufacture these nanotubes in, tiny lengths. We're talking centimeters, maybe inches.
Centimeters? But we need 23,000 miles.
Precisely. Imagine trying to weave a rope nearly to the moon out of threads that are only an inch long. That's the scale of the manufacturing challenge. It's not just about the material's properties. It's about producing it continuously, reliably, over thousands and thousands of kilometers.
Wow. Okay. That's a massive material science problem. What else?
Well, beyond the material, you've got the orbital mechanics. It's incredibly complex. The elevator cable needs to be held taut, right, like a plumb line to space. To do that, and to keep it rotating perfectly with the Earth, you need a huge counterweight, way out beyond geostationary orbit.
A counterweight, like what? Asteroid?
Could be. Or just a massive station built out there. But it needs to be heavy enough and far enough out to keep the whole structure under tension, perfectly balanced as the Earth spins. It's like swinging a weight on a string.
Okay, so the engineering is just staggering. But let's say, hypothetically, we solve all that. We build it. What's the ride like? How does it compare to blasting off in a rocket?
It'd be different, very different. Your sources suggest climber speeds might be maybe 100, perhaps 200 miles per hour.
That sounds fast, but over 23,000 miles.
Exactly. It means the trip up would take days, probably somewhere between 5 and 10 days to get all the way to geostationary orbit.
Days compared to minutes in a rocket.
Right. So much, much slower. But think about the advantages. It promises to be far safer, no controlled explosions needed, and it would be fully reusable. The climbers just go up and down. Plus, potentially much cheaper, especially for cargo.
Okay, so for things that aren't time sensitive, sending up construction materials, supplies. It could be revolutionary.
That's the idea. It could completely change the economics of getting mass into orbit.
It's fascinating because, we are seeing big advances in rockets lately. Reusability is coming along, costs are dropping. So why does this space elevator idea still hold such fascination? Why keep pursuing this almost mythical challenge?
That's a really good point. Even with better rockets, the elevator represents a fundamentally different capability. A paradigm shift, really. If you connect it to the bigger picture, think of it as a permanent spaceport, a stable anchor point in geostationary orbit.
A spaceport. What does that enable?
Well, imagine launching missions to the moon or Mars, or even further out from that point.
Yeah.
Spacecraft could be assembled there, refueled, repaired,
Yeah.
all without having to constantly fight Earth's deep gravity well every single time you launch.
So it's not just about getting to orbit, it's about what you can do from orbit more easily.
Precisely. It could be the gateway, the infrastructure needed to really open up the solar system, making interplanetary travel much more efficient.
So, thinking about all this, the immense challenges, but also the incredible potential, here's something for you to ponder. If humanity could crack this, if we could overcome these huge technological hurdles and actually build a space elevator, would it just change how we get to space? Or would it fundamentally alter our entire relationship with the cosmos? Could this be the kind of project that truly makes us a multiplanetary species? Something to think about.